Good day, everybody. How are you all, my friends? I hope you are doing great. Today, we are going to talk about hypothesis test comparing two different population proportions. So I'll share my computer screen with you. A survey found that 31% of people in the age group 33 to 49 rated a landline telephone among the three most important services they purchase. In another representative sample of age group 50 to 68, 48% rated a landline telephone among the three most important services they purchased. Suppose the sample were independently selected and the sample size was 600 for the 33 to 49 age group and 650 for the 50 to 68 age group sample. Does this data provide convincing evidence that the proportion of adults in the age group 33 to 49 who rate a landline telephone in the top three is less than the proportion of adults in the age group 50 to 68? Use a level of significance of 0.05 to test the relevant hypothesis. Okay. So let's get started on this. Solution. Okay. Let 1 equal to age group 33 to 49 and 2 49 and 2 is age group 50 to 68. Given. Okay. P1 hat. This is sample proportion of 1. Proportion of 1, group 1 is equal to 0.31, N1 equal to 600, and then P2 hat, sample proportion of group 2 is equal to 0.48, and the sample size, comma, N2 is equal to 650. So our null hypothesis is H sub 0 colon P1 equal to P2, where P1 is population proportion of group 1, population proportion of group 1, okay, and P2 is equal to population proportion of group 2. Okay, so that's our null hypothesis. Then what is the alternate hypothesis or the test hypothesis? The alternate hypothesis, as stated in the problem statement, is P1 is less than P2. Okay. So, first thing we will check the where check. Check N1 times P1 hat is equal to 600 times 0.31. This is the number of successes in the group 1, and that is equal to 186, which is greater than 10. Okay. Also, N1 times 1 minus P1 hat is equal to N1 minus N1 P1 hat, which is 600 minus 186 is equal to 414. That is also greater than 10. We also check in the number of successes in group 2. N2 times P2 hat is equal to 650 multiplied by 0.48 is equal to 312. That is greater than 10. And number of failure, N2 times 1 minus P2 hat is equal to N2 minus N2 P2 hat is 650 minus 312, which is 338, which is also greater than 10. So these tell us that the probability distribution of P1 hat and P2 hat can be both assumed to be normal. Hence, the difference of the two population or two sample proportions, P1 hat minus P2 hat, is also bell-shaped. So let's move this up. Since all the conditions of that is greater than 10 are met, we can assume that the sampling distribution of P1 hat minus P2 hat is bell-shaped or normal. And we can proceed with the test. Proceed with the hypothesis test. Okay. So, wait a minute, don't leave. I will give you some important hint or tips at the end of this, towards the end of this presentation. So just hang on a few more minutes, okay? So what do we now calculate? We will now calculate PC hat. This is both conditions are met is bell-shaped. Okay, so we want to calculate PC hat, which is a combined estimate of a common population proportion. Combined estimate of a common population proportion. Common population proportion. And PC hat is given by PC hat is equal to N1 times P1 hat plus N2 times P2 hat divided by N1 plus N2, which is 186 for N1 P1 hat as we calculated in the first step, and N2 P2 hat is 312. And the whole thing is divided by 600 plus 650, which is 498 in the numerator divided by 1250 in the denominator is equal to 0.3984. Okay. So now we are ready to calculate the test statistic, which is in which we are going to compare the two sample proportions. Okay. So what is the formula for the test statistic, where we are going to compare the two sample proportions? So maybe I should change the color of the ink just to make it a little interesting. So the formula for the test statistic, Z is equal to P1 hat minus P2 hat divided by square root of PC hat times 1 minus PC hat divided by N1 plus PC hat times 1 minus PC hat divided by N2, everything under the square root. Okay. So now let's plug in the values, which we already know. P1 hat is 0.31. P2 hat is 0.48. So we are comparing the two sample proportion and then dividing by the standard deviation of the sampling distribution of the two difference, P1 hat minus P2 hat. And that is equal to, we'll plug in the values, which is 0.3984 times 1 minus 0.3984. This is common in the numerator of both the terms in the denominator. And you multiplied by 1 over 600 for N1 plus 1 over 650 for N2. Okay. So if I do the calculations correctly, my test statistic will come out as Z is equal to minus 6.133. That's my test statistic. What does it mean? It means P1 hat is less than P2 hat. Sample proportion of first group is less than the sample proportion of the second group by 6.133 standard deviation of the sampling distribution of P1 hat minus P2 hat. Okay. Now, is that large enough? Is that difference large enough to reject the null hypothesis? So we need to find out what is the probability value of getting a test statistic as extreme as minus 6.133. So if I create, so please do not leave, do not quit. I'll give you the tips for doing this. So here, think of the standard normal curve. This is the Z curve. This is the standard normal curve. Or Z curve. Okay. And at the center, I have Z is equal to 0, where the peak is the highest, right? Now my test statistic is minus 6.133. So where is this minus? It's way in the left tail. way in the left tail, very, very far away from the center, somewhere over here, minus 6.133, which is my test statistic. Remember, Z is my 6.133 is my test statistic. So the p-value, remember our null hypothesis is H0 is P1 equal to P2, and the alternate is P1 less than P2. So it's a left tail test. So p-value is the area to the left of minus 6.133. As I already explained, this test statistic is way in the left tail. So the p-value to the left of it, this area, should be very small. So we can use the calculator to find the p-value to the left of. So this area is the p-value to the left of the test statistic, minus 6.33. We can use our calculator, TI-84, and find that area. So we can use the second button, then the worst button, then number 2, which is normal CDF. My lower bound is usually in the calculator minus 1 E99. That means a very large negative number on the left. And my upper bound, I'm starting from negative infinity, very large number on the left-hand side, negative value. And I'm stopping at, let me move this a little bit. Give me a minute. Yeah. So my upper, and my upper is minus 6.133. My mu is 0 because this is a standard normal curve. Sigma is 1. So the area, area to the left of minus 6.133 is probability Z less than minus 6.133. 6.133 is 4.36 E minus 10. What does it mean? There are 9 zeros. 0.1, 2, 3, 4, 5, 6, 7, 8, 9. And then in the 10th place after the decimal is 4. This is almost equal to 0. Now, let's move this a little bit. Okay. Compare the p-value with the alpha. Compare p-value with alpha. Remember, alpha is 0.05, I believe. Let me check and make sure I'm doing the correct thing. So, it's 0.05, yeah. So alpha level of significance with 0.5. So P is 0. So P less than alpha. Decision is reject H0. Conclusion is at alpha is equal to 0.05. There is enough evidence to support. Enough evidence to support the alternate. The alternate hypothesis which states P1 is less than P2. And that is because the probability value of getting a test statistic as extreme as minus 6.133 is almost zero, which is less than the level of significance. Therefore, we reject the null hypothesis. Now, I was going to give you a tip at the end, and the tip is the same problem can be done with the calculator. If you have TI-84, you press the stat button, then highlight test on the top row, and then scroll down to 2 prop Z test, and you can do this test. Okay. I will stop here today. If you have any question or comment, write me a note. If you like this video, please give me a heads up. If you like this video, please share this video with your friends. Again, if you have any question, comment, you can write to me. I'll get back to you as soon as possible. And if you like this video, please share with your friends. And you and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I will be back next time with another hypothesis test problem. I come back every day with new problems. My goal is to help you succeed in math, okay? Take care. Have a nice day. Thanks for watching. See you next time.